Hello and welcome back to the course. Today we're talking about the neuron, which is the basic building block of artificial neural networks. So let's get started. Previously, we saw an image which looked like this. And these are actual real life neurons, which have smeared on to glass, colored a little bit, and they are observed through a microscope. So this is what they look like. As you can see, quite an interesting structure, a body and a lot of different tails, kind of branches coming out of them. And this is very interesting, but the question is, how can we recreate this in a machine? Because we really need to recreate that in a machine, since the whole purpose of deep learning is to mimic how the human brain works, in the hopes that by doing so we are going to create something amazing. We are going to create an amazing infrastructure for machines to be able to learn. And why do we hope for that? Because the human brain is happens to be one of the most powerful learning tools on the planet, or like learning mechanisms. And we just hope that if we recreate that, we'll have something as awesome as that. So, our challenge right now, our very first step is to create artificial neural networks to recreate a neuron. So, how do we do that? First, let's take a closer look at what it actually is. This image was first created by a Spanish neural scientist, Santiago Ramon y Cajal, in 1899. And what he did was he dyed neurons in actual brain tissue and looked at them under a microscope. And while he was looking at them, he actually drew what he saw. And this is what he saw. He saw two neurons, or two large neurons over there at the top, which had all these branches coming out of them towards their top parts, and then each had a rod or thread coming out towards the bottom. Very long one. And that's what he saw. And now you know technology has advanced quite a lot, and we have seen neurons much closer and more detailed, and now we can actually draw what it looks like diagrammatically. So let's have a look at that. Here's a neuron. This is what it looks like. Very similar to what Santiago Ramon drew over here. Here in this neuron, what we can see is that it's got the body, that's the main part of the neuron, and then it's got some branches at the top, which are called dendrites. It's also got an axon, which is that long tail of the neuron. So, what are these dendrites for, and what's the axon for? Well, the key point to understand here is that neurons by themselves are pretty much useless. It's like an ant on its own can't do much. Like five ants together, maybe they can pick something up. But again, they can't build an ant hill. They can't establish a colony. They can't work together as a huge organism. But at the same time, when you have lots and lots of ants, like you have a million ants, they can build a whole colony. They can build an ant hill. Same thing with neurons. By itself, it's not that strong, but when you have lots of neurons together, they work together to do magic. And how do they work together? That's the question. Well, that's what the dendrites and axon are for. So the dendrites are kind of like the receivers of the signal for the neuron, and axon is the transmitter of the signal for the neuron. And here's an image of how it all works conceptually. So at the top, you got the neuron, and you can see that its dendrites are connected to axons of other neurons that are like even further away above it. And then the signal from this neuron travels down its axon and connects or passes onto the dendrites of the other neuron. And that's how they're connected. And in that small image over there, you can see that the axon doesn't actually touch the dendrite. A lot of machine learning or a few machine learning scientists are very adamant about the fact that it doesn't touch. It doesn't touch. It has proven that there is no physical connection there. But the point that we are interested in is that the connection between them, that the whole concept of the signal being passed, that's called the synapse. You can see over there in that little image that figure bracket is synapse. That's the term we're going to be using. Instead of calling our artificial neurons the lines we're going to have or the connectors for artificial neurons, we're not be calling them axons or dendrites, because then the question is, whose connection is this? Is it that neurons, or is it this neurons? We're just going to call them synapses. And that kind of just answers all the questions. I mean, it's basically just where the signal is passed. Doesn't matter who that element belongs to. That's just a representation of the signal being passed, and we see that just now. So basically, that's how a neuron works. Let's move on to how we're going to represent neurons, or how we're going to create neurons in machines. So now we're moving away from neural science and moving into technology. And here we go. So here's our neuron, also sometimes called the node. The neuron gets some input signals, and it has an output signal. So dendrites and axons, we're gonna call this synapses. This input signals, we're going to represent them with other neurons as well. So in this specific case, you can see that this neuron, this green neuron, is getting signals from yellow neurons. And in this course, we're going to try to stick to a certain color coding, and where yellow means an input layer, and basically all the neurons that are on the outer layer, on the first front of where the signals coming in. By signal, it might be a bit of an overkill to call this a signal. It's just basically input value. So you know how even like in a simple linear regression, you have input values and then you have a predicted value. Same thing here. So you have input values, and there they are, the yellow ones. And on the right to you, we see just now it will be red. It's the output value. The thing that I wanted to point out here is that in this specific example, we are looking at a neuron which is getting its signals from the input layer neurons. So they are also neurons, but they are input layer neurons. Sometimes you'll have neurons which get their signal from other hidden layer neurons, so from other green neurons. And the concept is gonna be exactly the same. Just in this case, for simplicity's sake, we're portraying this example and in terms of the input layer. The way to think about it is in the analogy of the human brain, the input layer is your senses. So whatever you can see, hear, feel, touch, or smell, And of course, there's a lot of things you can see, there's a lot of information coming in, but um, those are your input signals. So our brain can see, can hear, can feel, and so on. So these are uh, coming in from the organs, which are called our ears, nose, eyes, our sense of touch, and whatever, and our taste. It's just getting signals, but it's basically uh, the brain basically lives in a dark black box, and it's making sense of the world through our senses. So you have these inputs that are coming in, and in terms of human brain, those are your five senses. In terms of machine learning or deep learning, that is basically your input values. So your independent variables. Our input values are also called independent variables. And we will get to that in a second. So your input values, the signal is passed through synapses to your neuron, and then your neuron has an output value that it passes further on down the chain. And in this specific case, in terms of color coding, again, yellow means input layer. So we kind of simplifying everything here. We're saying we're only gonna have like the input layer, then we're gonna have one hidden layer with the green, which is a hidden layer, and then we have output layer right away. So just so that we can get used to those colors for now. So there you go. That's the basic structure. So now let's look at a bit more detail at these different elements that we have. So we got the input layer, and we have these inputs, which are in fact independent variables. So independent variable 1, independent variable 2, and independent variable m. The important thing to remember here is that these independent variables are all for one single observation. When we say single observation, that's one row of your database. If you can still remember in your database concepts, right? There's one record, which is equivalent to one row. That's also called one observation. So these independent variables are talking about that one single observation. You just take all of the independent variables. Maybe it's the age of the person, the amount of money in their bank account, how do they drive or walk to work, what method of transportation do they use. But that's all descriptions of one specific person that you are. Either you're training your model on or you're performing some prediction on. And the other thing you need to know about these variables is that you need to standardize them. You need to either standardize them, which means make sure they have a mean of 0 and variance 1. Or you can also sometimes, uh, you might come up, we will be, come, we will come across, we will have to, you will come across this standardization and normalization in our practical demonstrations. And sometimes you might want to not standardize, you might want to normalize them. meaning that instead of making sure that mean is 0 and variance is 1, you just subtract the minimum value and then you divide it by maximum minus minimum. So by the range of your values, and therefore you get values between 0 and 1. Depend on the scenario, you might want to do one or the other, but basically you want all of these variables to be quite similar in about the same range of values. Why is that? Well, all of these values are going to go into a neural network where, as we all see just now, they will be added up and multiplied by weights, added up, and so on. It's just going to be easier for the neural network to process them if they are all about the same. And that's just how it is going to be able to work properly. And if you want to read more about standardization, normalization, and other things you can do with your input variables, a good addition reading paper is called Efficient Backprop by Jan LeCun, 1998. The link's over there. So Jan LeCun, we're actually going to talk about this person in the place of deep learning in the part of the course where we're talking about illusional neural networks. You'll see that this is definitely a person who knows what he's talking about. He's a close friend of Jeffrey Hinton, who we've already mentioned in the previous lecture. So, in this paper, you will learn more about standardization and normalization. So, we don't know exactly how standardization and normalization work right now. We're just presenting to you that we need to standardize and normalize our input values in our neural network. And we will have a demonstration of that in our practical um, hands on exercises. But you can pick up lots of other different tips and tricks and be a good source of additional reading as you go through this course. So, check out if you're interested in some additional reading. There we go. So that's what we need to do with the variables. And here we've got the output value. So what can our output value be? Well, we've got a couple of options. Output value it can be continuous, for instance, rise. It can be binary. Binary means that the value of that variable um, will be can be in two from the term binary. It has two values. Example is whether a person will leave or stay. Or it can also be a variable can also be a type of a categorical variable. If it's a categorical value, the important thing to remember here is that in that case, your output value won't be just one. If categorical, then multiple values, then we will have multiple values like in this illustration. It will be, if it's categorical, then it has several output values. In this illustration, we showed the output value 1, y1, y2, and y3. Because this will be your dummy variables, which will be representing your category. So assuming that the output values are category A, category B, category C, and so on. So those are examples of categorical, and that's how it works. Just important to remember that in that case, that's how you're going to be getting your categories out of the artificial neural network. But let's go back to our simple case of one output value. And now one more point. I just want to I reiterate this point. On the left, you've got a single observation, so one row from your data set. And on the right, you have a single observation as well. That's the same observation. So important to remember that whatever inputs you're putting in, that's for one row. And then the output you get back is for that exact same row. Or if you're training your neural network, then you're putting the inputs in for that one row. You're putting the output in for that one row. If you wanna simplify the complexity, think of it as like a simple linear regression or a multivariate linear regression. So you're putting in your values and then you have your output. We're just putting in values and then we're getting an output. But just remember that every time it's one row that you're dealing with. So you don't get confused and start putting in, like thinking these are different rows that you're putting into your artificial neural network or something. This is all just values in that one row. So different observation, different characteristics, or different or attributes relating to that one observation every single time. Okay, so next thing that we want to talk about here is the synapses. Here we've got synapses and they all actually get assigned weights. We're gonna talk more about weights further down, but in short, weights are crucial to artificial neural networks functioning because weights are how neural networks learn. By adjusting the weights, the neural network decides in every single case what signal is important and what signal is not important to a certain neuron. What signal gets passed along and what signal doesn't get passed along. Or to what strength, to what extent signals get passed along. So weights are crucial. They are the things that get adjusted through the process of learning. When you're training your artificial neural network, you're basically adjusting all of the weights in all of the synapses across this whole neural network. And that's where gradient descent and backpropagation come into play, and those concepts that we'll also discuss. So basically, those are the weights. That's all you need to know for now. And here we've got the neuron. So signals go into the neuron, and what happens in the neuron? This is the interesting part. We're talking about the neuron, what happens inside the neuron. So a few things happen here. First thing, and the first step is that all of those values that it's getting are added up. So it takes the added, so the weighted sum of all the input values that it's getting. Very simple, straightforward. Just add up, multiply by the weight, and add them up. And then it applies an activation function. Now we're gonna talk more about activation function in the next lecture further down, but it's basically a function that is assigned to this neuron, or it is applied to this weighted sum. And then from that, the neuron understands if it needs to pass on uh, a signal. That's the signal it passes on. The function applied to the weighted sum But basically, depending on the function, the neuron will either pass on the signal or it won't. But basically, depending on the function, the neuron will either pass on the signal or it won't pass the signal on. And that's exactly what happened here in step 3. Here, in step 3, the neuron passes on that signal to the next neuron down the line. And that's what we're going to talk about in the next lecture video, because it is quite an important topic. We want to delve deeper into the activation function, but hopefully for now, this is to show you how the flow from the input to the output values are gonna happen. So hopefully for now, everything is or should be pretty clear, and it's how you've got input values, then you've got weights, the synapses, and then something that happens in the neuron, and you have the weighted sum, and then the activation function applied to them that is passed on then that is repeated throughout the whole neural network, on and on. So thousands, hundreds, or thousands of times, depending how big, how many neurons you have, how many synapses you have in your neural network. So there we go. Hope you enjoyed today's lecture. We will see you in our next lesson, which is the activation function.